here, which is really the idea of building out things with the mindset of reliability. And I think that's a really important topic, is to think about not just creating the original idea, which is a lot of what data science and machine learning is, but actually how do you make it reliable? And I've actually spent pretty much my entire adult life solving that problem, and so I have some opinions about it. Maybe some of them are good, and really to start off with, let me talk a little bit about my background here, which I think would help a little bit. Is that I've been working in the film and TV industry for a lot of the early part of my life. When I was a teenager, my dad had a television production company, and I got to see the evolution of technology in that industry, going from physical hardware to virtual. And you would see this a lot with the way that people would have to constantly learn the new techniques. And that's when I got really involved with thinking about automation. And then later, after I graduated from college, when I was in Los Angeles, I worked in Disney's first 3D animated pipeline. So this was when they were competing with Pixar, and they were really kind of trying to figure out who's going to build these 3D animated pipelines. And one of this was, I think, in 2004 or so. And so what was really interesting about this is that film, especially the early days, was a heavy user of Python. And what did we do every day? Well, we just automated things. That's literally all you do in the film industry. I think a lot of people think about it's a glamorous industry, and there's some fun things about it. But really, if you're a software engineer, you just automate everything. Every day you just build stuff that makes things quicker and more efficient. And that mindset is actually identical to what we need today with MLOps. So I feel like that experience really was helpful. And one of the things that I did, in the last, let's say 15, 20 years was write about it. And so about 15 years ago, I'll just hold this up, I wrote this book for O'Reilly called Python for Unix and Linux Systems Administration. And the idea in the book was to essentially, figure out how to automate things, right? And that was the essence of the book. And then a little bit later, as I moved around the world and went to different places, and I came back to the Bay Area, I helped build a social media company. This was 2013. So I was a little bit early, because it seems like everybody's interested in social media now. And we did some really interesting things. And one of the things that we did that was interesting was used MLOps to drive basically user growth. So we bought no advertising, and we were able to figure out the influencers by creating MLOps pipelines, using that predictive model to then choose who to partner with. And then we paid essentially influencers or influencer marketing to actually grow our platform. And so I wrote about some of those experiences in the next book, which is Pragmatic AI. And so this was really, I think, the start of me writing about, MLOps and covering those kinds of topics. And then after that, I decided to leave the startup world and get more into consulting and teaching. And that's what I've been doing since about 2016. I've been focused on that. And a lot of the focus is around, operationalizing thing. And I wrote a couple more books for O'Reilly. So one of them was this one, which is Python for DevOps. And so that's, again, automation, right? How do you build things that are automated, especially in terms of cloud computing? And then after that, I wrote another book for O'Reilly, which is Practical MLOps, which really, I think, does cover some of the things that people are talking about quite a bit now. And it's a very simple book, in my opinion, like really high level concepts, nothing too tricky. And then recently I wrote one more book for O'Reilly, which is the C# book for AWS. So I thought I would just cover that so that people had a little bit of perspective of where I'm coming from, why am I saying these things, and then I'm currently writing another book on implementing MLOps. So I've been really thinking about MLOps quite a bit for the last, let's say, 15 or 20 years. So here's some of the things that I've found, and one of them is this concept of preemptive risk discovery. And this is why it's important to think about automation from the very beginning when you're building something or you're building a machine learning model. And what I mean by this is that if anything in an organization is not automated, then there is risk. And there's no ambiguity about that. And when I was in the Bay Area, a lot of the kinds of problems that I was put into, there was a company that had a problem with shipping software for a year, or there was a product that couldn't launch, et cetera, et cetera. At the root of every single one of those problems was a lack of automation. Similarly, if there are problems with quality control in a company, if you look at the root of that, it's going to be lack of instrumentation, lack of monitoring. I think for data scientists, fortunately, it should be pretty easy to explain to people how important it is to look at data, right? Like if you can't convince a data scientist it's important to look at data, then all hope is lost. But it may be a little more difficult to talk to software engineers about it. But for data scientists, the way to think about this is that you must use data science as well for the thing you put into production. If you don't know what's happening in production, how can you possibly fix it, right? And this is a really core problem that must be solved. And then quality control. And this is a very interesting one too, because if you think about data, a lot of times people are very concerned about, bias and, bad problems and null values and corrupt data and all these other issues that come up. But the same goes with software, right? Software is actually just data. And so you look at the code, if you don't have automated quality control systems to verify that the syntax is correct or that the business logic is correct, you're going to have risk. And so this is one of the key problems that a continuous integration system will solve. And fortunately, it's actually very straightforward to do this. If you add automated quality control, you're going to reduce the risk in your organization. And it's trivial and it saves time. Another one I think that is I don't know if it's talked about enough, but I have deep concerns about this because I am in academics right now. So I work at Duke and I teach machine learning operations. I teach cloud computing. I teach data engineering. I've taught at lots of other universities, but I also am more of a practitioner. I would say I'm an accidental academic. And I think the academic tool chain is extremely dangerous. And the reason why I think it's extremely dangerous isn't that the people that are building it are not smart. Of course they are. They're brilliant people, but it's that the platform that they're building in or the ecosystem that they're building in is designed to be fragile, is designed to be really experimentative. But when you think about production, you want the opposite of that. You want rigidity, you want immutability. And so I think it's very important to be careful about choosing tools or platforms or solutions that are 100% focused on reproducing the academic toolchain, because it may not be appropriate for an organization that is trying to solve a business problem. So this gets me to the next point, which is that if you don't do DevOps, you don't do MLOps, right? It's that simple. And in a sense, it is nice to have simple rules for things, because when you have simple rules for things, then it makes it easier to understand what's happening. And this is where I think I find sometimes a little bit shocking if somebody's talking about MLOps and they're talking about all the different things they want to do with data science to make it better. I think the very first question any organization should do is ask, do you do DevOps? So if the answer is no, how could you possibly do MLOps if you're not doing DevOps? And I'll get into some of the things about DevOps really, really briefly. So what is DevOps? I mean, in a nutshell, DevOps is automation. So it means that you can automatically deploy your software to production. If you want to read more about it, obviously I have some books on O'Reilly, you can read about it. But basically, if you have full automation, you have continuous integration systems, you have infrastructure as code, you're using the best practices, then you're doing DevOps. If you're not doing that, there's deep trouble that you must first fix. So let's assume that you've done it and now you fixed it. Those same things that you've learned in terms of automation, now you should apply to the other parts of the pipeline. So also with data automation, you must go through and make sure that the data pipeline is automated. If it's manual, then you're going to have all of the same problems of why people don't want manual software engineering practices. Humans are unreliable, humans introduce errors, et cetera, et cetera. So you want full data automation. Likewise, platform automation, it's really probably not going to work out well for an organization to build their own platform. There are obvious exceptions, and those really reinforce the rule. Like if you're a huge organization that specializes in MLOps, maybe you can make the case to build a platform, but in general, you should pick something. I'm not going to tell you which platform to pick, but you should pick something where there's a vendor that has actually spent their time building a system that is widely used so that your organization doesn't have to do that and you can focus on the business problems. Once you have those three layers, then you can do MLOps. And I think this is a really important chart to show, because I think it is the way forward for many organizations. Now, one other thing I'll mention about this is what I call the rule of 25. And what the rule of 25 means is that there is no silver bullet. Just like if you go into data science land and you talk about area under the curve, or the precision recall and the balance between those things, like there is no perfect way to describe an accuracy metric. Likewise, there's no perfect way to describe MLOps. There is no silver bullet. And I would say anytime you hear somebody talk about a silver bullet rule for anything, let alone something as complex as machine learning operations, you should have your guard up, because there's no perfect answer, right? There's always a trade-off with complex systems. And I would say this is a better way to think about it, instead of listening to some perfect silver bullet answer, is that there's going to be trade-offs, and you're going to have to spend 25% of your time doing DevOps. So you must have continuous integration, build system, infrastructure as code, microservices, containers, those kinds of things. You're going to have to spend 25% of your time with the data. You have to make sure that there's data automation. There's systems that are high-level systems that are reproducible, that your organization is trained on. And then obviously with machine learning, you must do modeling, right? You can't have MLOps if there's no models. So you have to have some time you spend on those models, and you have to make sure that they're accurate. And then I think the other part that isn't talked about quite enough is that you have to clearly define the problem that you're trying to solve. So if you haven't defined the problem correctly, even those other three categories are useless, right? So if the organization is trying to figure out how to classify, between two categories, let's say, can I pick between, this machine we created let's say a tractor and a car. Like I want to do some kind of image classification, and that's the problem that the business wants you to solve. But then you solved like a regression problem that does a numerical prediction that forecasts the sales for the tractors. Well, it could be an amazing model that has absolutely nothing to do with what the business needs. So if you're building the wrong model and the wrong solution, then you haven't really applied the 25% to the business. And this is why it's so hard, is that all of these four things have to be in balance with each other in order to do MLOps. And so that brings me to the next section, which is talking about monitoring. And my definition of monitoring is it's data science for a software system. And I think that's one of the best ways to describe it. And if you ask a data scientist who's digging into the details of some problem, what kind of thing do we care about with a problem? Well, I mean, typically the more variety of data, the higher quality of the data, these are good, right? Like if you're doing data science, you want this, you want more data, higher quality data. Likewise, if you're looking at a system, if you can have lots of different things you're measuring, the CPU, the disk IO, the latency, the model accuracy, the data drift, it's just going to make it much, much more simple to diagnose the root cause if there is an issue in production. So in some sense, you could make the argument that you could never have too much monitoring and instrumentation. That's an argument I think many long-time software engineers would probably attest to. And I would say the same thing for MLOps, is you probably cannot go wrong with spending time making your system more able to be instrumented. I think it's a very good use of your time. Now, if we get into a quality control system, I think this is an emerging category, and this speaks to what I was talking about the academic tool chain, is that in the academic tool chain, the thing that is the prestige in academics is writing research papers. And there's obviously an incredible service to society that is done by people, collaborating on research. And so as a result, there's a lot of conversations about reproducibility, and that's what people use notebooks and those kinds of things. But that particular system isn't a direct mapping to a production software system. And in a production software system, one of the things that's more important than some of those factors in research are that you're designing a system from the very beginning to be production first. So you have a production first mindset versus an academic first mindset. What that means is that ideally you could have the same environment that it'll be deployed in is what you're developing in. And that's why products like cloud-based development systems are really, I think, one of the secret weapons for MLOps. So can you use GitHub code spaces? Can you use, AWS Cloud 9? Can you use Google Cloud Shell? Can you use Azure Cloud Shell? Can you use these cloud-based development environments and actually have a Docker file that has literally the same thing that will go into production? That's amazing. Likewise, access to GPUs while you're working can be really helpful, especially if they're on-demand GPUs, so you can really replicate the same environments. And I think another one that's emerging is that if you're a data scientist, we shouldn't need to convince you that why wouldn't you use data to make decisions? Likewise, why wouldn't you use pre-trained models that can help you write code to build production systems? And I think it's going to come to the point now where it's going to be very difficult to justify not using some kind of AI coding assistant, because it increases the quality of the code you write, and it improves how quickly you can write code. I personally now have completely gone towards using tools like Copilot. And then finally, as I mentioned before, continuous integration and deployment is from the very beginning, maybe one of the first things that you should set up. So these are fairly new emergent properties that we're seeing with MLOps. And I believe if you do adopt them all, you can dramatically change how quickly you develop results. So let's talk a little bit about this concept of reproducibility here with code spaces, and in particular with a cloud-based development environment. What is really nice about it is that you're able to build the different components, right? You can build a container image, and that exact image can be started from somebody else on your team, and you can share it with everybody else. And that's a critical component to building out solutions. You also could develop with some kind of configuration that has the right plugins and the right software, environments, and it could be tuned to the cloud or the data center that you're actually developing towards. So you have this deep integration. And then also the compute and storage can withstand the needs of what you're doing for data science. So there are many reasons why it's superior to your laptop, and your laptop or even your workstation can't compete with some of these things. They just are not really possible. And if you took the network alone, right, where if you're in a cloud-based environment, you're potentially on the same rack as the machine you're talking to. And so the speed is very fast, versus if you're on your laptop, the speed to, throw data back and forth between the cloud is just not feasible for many problems. So I do believe this is a secret weapon that many organizations should really seriously consider. And as I mentioned before, another secret weapon that we're seeing is that a AI coding assistant, and there's many companies that are making them, not just GitHub, that I think it's dramatically improving the quality of code that you can write. So the idea is that just like with the data science problem, you have to ask the right question to start with, like, what's my hypothesis? You have to ask the right questions to these pair programming tools. And you notice that the better you get at understanding how the tool will respond to your question, the better the result is going to be for you to get it back. And one of the things that I've been doing quite a bit is I actually have a tool that refactors my code once I get it from the AI assistant. So basically I ask the AI assistant, hey, build out a PyTorch system that pre-trains a model, blah, 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 blah. And then what I do is I have a make file where I lint the code and I test the code and I basically format it. So it's constantly, I have my own analog tools, like old school tools that are combined with the new tools. And I can improve the quality before I even check it into the system. Then once I check it to the system, it itself also has all these quality control tools. So what we see here is that there's essentially these recursive techniques to improve the quality. So you have, an AI assistant that approves. You have also the local tools like linting and formatting that improve. And then you have the build system, which improves. And then when you put it to production, you improve. And so the more you can combine these recursive tools to help you build software more reliably, the better the results are going to be, downstream. And one way to really call this out would be to call this Kaizen, right, or continuous improvement. So every single both main component and then subcomponent needs to have continuous improvement. So let's talk a little bit about a tool like GitHub Actions, which I think is one of the better tools out on the market. If you're doing data science or doing MLOps, I strongly believe that a code space plus a GitHub action and using a makefile where you have steps clearly defined, like a make install, a make test, a make deploy, and you can replicate that in your code space, which should be identical to what production is because you're using a Docker file that has the exact same components. You can then push this into your Git repo. It triggers GitHub Actions, which then could maybe build a container, push that container image into a container registry like Amazon ECR. And that container is immutable and it's identical to what you just did locally. That container could then trigger a deploy. And what we're seeing as well with a lot of cloud-based systems is that as long as you have a container that has all of the components necessary, most deployments now will actually slurp in that container image and deploy it into production. So one example would be App Runner deploying a fast API service. We also have AWS Lambda that can slurp in containers. We have Google has the ability to slurp in a container one-liner that deploys into production. So if you start again with a production mindset and you have a Docker container, you've saved all this work because the system that is in the cloud can just take the container and deploy it to an environment. So I think this is also a very good secret weapon to have, is to think about if your in target is a container, you can deploy with that containerized environment and have a very simple workflow to deploy your model into production. And, I'll just talk a little bit about this because this is kind of a hot topic for me lately, is this concept of the academic data science toolchain. So obviously academics need tools to help them do their job. On the flip side, I think there are going to be the trade-offs, right? And so we can see the same kinds of problems as if you over-optimize towards one thing, you're taking away something from something else. And I think notebooks are a very interesting one, and I'll give you a little bit of background about notebooks from my perspective, is that I've been using notebooks in the notebook technology literally probably the week they came out. So I've been using IPython, which is the precursor to Jupyter Notebook, back in 2006 or 5, whenever it came out. And I'm a huge fan of it. And I still use it quite a bit in terms of doing software engineering. One of the problems though with a notebook is that it really is not designed for production software deployment, right? It's designed for experimentation and reproducible experimentation. A production system by definition needs to be immutable. And so I think one of the things that we're seeing here is that many tools are now starting to attempt to address the notebook issue. And I think we're going to get to a place where the majority of people that are doing MLOps will not start off with a notebook. I think instead what a notebook will be is it'll be a complementary tool, right? So people will need to explain their model maybe, or do something with it, or explain some part of the data science problem. Great. Yeah, let's use the notebook. But to start with a notebook, I think is a very bad idea. And I think we're not seeing that yet. That's my opinion, though. I think we're going to start to see there's some pushback. The other one that I'm not a fan of is God tools. And what is a God tool? So a God tool is something that basically it does everything, right? Like it takes over your entire environment and solves every single problem. I think these can make a lot of sense in academics, right? So like people can need, to have, let's say you have a very expensive GPU. Well, sure, why not have a God tool, right? Because how many expensive GPUs can you distribute to everybody in your university? But in a sense, a God tool is really a way of building software that assumes you have the equivalent of like a mainframe computer. But in the future, I don't think we want as much of a reliance on a God tool. We want extremely simple systems that barely use anything. And so I would say one of the advantages of a tool like Docker is it's decomposable, right? And so I would say the opposite of a God tool would be something like Docker. You look at a Docker file, it historically has lots and lots and lots of different things that you can pull back from, and you can pull out pieces that you want. Another one I would say is a voodoo tool as well, which is that also I see this a lot in academics, is that if there's a tool that doesn't have reproducibility or idempotence associated with it, so essentially it's non-deterministic, that could be amazing for whatever it is that someone's doing. If there's some special flags, just like the mad scientist, right? If you're a data scientist, you know the picture of a mad scientist, their hair is like, on fire and they're doing beakers. You don't want that. You don't want that for production. You want simple tools. So the more simple, the more deterministic it is. Again, I think a Docker file is a good example of that you're going to have a better chance at success. And so really, to summarize everything together, this means production first mindset. And I think the tools that I would recommend that really help you do that would be containers, cloud-based development environments, and CI/CD. If you use these three